Silicon nanofibers test 1. 2 pieces of aluminum 6 inches by 6 inches square, 0.025 inches in thickness, had 2 grams of silicon nanofibers placed between it and clamped. The specimens were then hung on this bracket to have heat applied during the testing. The propane torch used has approximate high temperature heat at the tip of the flame of 3600 degrees Fahrenheit. Aluminum melts at approximately 1221 degrees Fahrenheit or 650 degrees Celsius. The propane torch will be applied onto the panel and heat will be allowed to disperse out through the panel before testing begins. The flame will be adjusted. Temperature of the panel at the start, room temperature and ambient temperature of the room is approximately 52 degrees Fahrenheit. Propane torch is lit. Has now been applied. As you can see, the heat spreading out through the panel. 52 degrees at the start. Panel's now up to 100 degrees Fahrenheit. The flame will be moved with the red dot measuring the temperature to the center of the panel. Temperature is now up to 180. 300. 500. As you can see, the material is starting to weld up. Starting to melt, approximately 1000 degrees. It exceeds the temperature range of the infrared thermometer. The aluminum is turning red hot. It's melting through. Temperature on the back of the panel is approximately 58 degrees. The torch is being applied directly onto the slag to melt away. The slag is solidifying. Now the flame is being applied directly onto the fibers. The nanofibers are absorbing the heat and displacing it out through the panel evenly. Again, the temperature of the flame exceeds the thermometer. It's been 2 minutes. The slurry is beginning to run more down the front of the panel. The overall heat of the flame is starting to buckle the aluminum, as you can see the pattern of the heat dispersed out through the panel. The flame will now be taken away and the panel will be removed so we can look at the internal damage to the panel, to the fibers if any, to the back panel if any, and to the back of the outside panel if any. Technicians are removing the specimen from the clamps. As you can see, the slag is re-solidified. Technicians are carefully trying to remove the front panel from the back panel. As you can see, the aluminum has melted onto the sheets and leaves a gaping hole in the front aluminum. As he pulls it away, trying not to damage it, the aluminum has melted onto the sheets. No damage caused by fire, no charring on the front of the sheet. As he turns it over, you can see the aluminum through the back of the sheet. That's how thin the 2 grams are. You see no burning, no charring, no flame damage to the back of the panel. This illustrates the heat dispersion and the resistance of the silicon nanofibers. The back plane of aluminum had no damage, no burning, no charring. The outside of the back plane had no damage, no charring, no burning. Thank you for your time.